Okay, this last circuit we're going to build is a real beast. This is the real stress test of the whole system. So the first thing we're going to do is in the bottom row, in the last compartment of the component box, is a 9-volt battery clip. Now these battery clips are a little bit annoying because they don't really have a clear indication of which wire is positive and which wire is negative. So I'm going to show you a little trick for that. If you grab a 2-pin board and get your active piezo buzzer from the box, so it's top row, left compartment, that's the one with a long leg and a short leg. If we put that into the connector with the 2 grooves on top with the lever, so we're going to put it so that long leg is to the left, short leg is to the right, and then press down the lever to seat it. I'm going to connect my battery clip to my 9-volt battery and try not to let the 2 wires touch each other. And what we can do is, if we go to the 2 female headers that are directly above the ground banana socket, if we just put those 2 wires in those headers, so I've put them in one way around and nothing has happened, so I know that the polarity is wrong. If I swap them around, so the other way around, I should hopefully, hear that piezo screeching. I think, yeah, there we go. So I'm going to take the piezo out entirely. So now I know that this battery block is set up the right way. So I'm going to very carefully hold those wires in place so that they don't slip out. And I'm going to move this battery block over to probably somewhere up in the top left of my board. So I'm going to make sure I have everything set up for this. You might have a more reliable connection if you make sure that you have those 2 wires in the right order and then move them over to the connector with the lever, but keeping them the same way around. So the one that was on the right is still on the right, the one that's on the left is still on the left. So I'm going to move that up to the top. I'm going to make sure that I have 6 2-pin boards ready and 2 3-pin boards. You will probably want to keep the 3-pin boards kind of close to you because these are where we're going to have like potentiometers that we control the circuit with later. So the new type of board that we're going to use is the board that has that lever connector with the 2 grooves in it that we've used before, and has 18 banana sockets around the outside. We're using that connector with the little lever in a different way this time. So within those grooves are actually a bunch of much smaller little sockets. On the 2-pin boards, they're all wired together to form a rail, but here we're going to use them individually. So each of these little sockets connects back out to one of these 18 banana sockets. So if you go to your component box again and bottom row and then 1, 2, 3, 4 over, you're going to find a couple of little chips. So dual inline package ICs. These are 555 timers that we have here. So we have 2 of them. If you put the chip sitting with its legs down on your finger, almost like a little ladybird sitting on your hand, and then feel along the top of the chip on its 2 short edges. Ooh, I've just dropped it. On its 2 short edges. One of them is going to have a little notch. It's quite hard to find, and on the particular 555s I have, it's shallow and it's not very pronounced. But you should, I hope, be able to find it. That tells you which way round to put your pin in. So we're going to be referring to the pins of the IC, of the 555 timer, as pin 1, pin 2, pin 3, pin 4, up to 8. So it's got 8 legs. If we are holding it, so that again, like a little ladybird, the ladybird has its back to us, it's facing forward, that's where its notch is. Its front left leg is going to be pin 1. And then coming down its left side, we're going to count towards ourselves. 1, 2, 3, 4. And that's its back left leg. Then we're going to move over to its back right leg, and that's going to be pin 5. And then moving forward, 6, 7, 8. So 8 is its front right leg. So we're going to count counterclockwise, starting from the top left. And I'm just going to, in this circuit, refer to, pin 1, IC1, or pin 4, IC2. So just bear in mind that we're going to count counterclockwise. If we come to our first 18 pin, our little chip breakout board, making sure that the lever is up towards the sky, we're going to try and seat this pin, or this chip, as far away from us in that socket as we can. So we're going to touch its 2 front legs off of the front of the grooves, and then just sort of let it drop into place and lock it in. One thing we can do, a little helpful feature, is these 2 grooves. You might have noticed that they have a little wall about halfway down that actually marks where the pin 4 kind of finishes on those sockets. So if your chip is now sitting snugly as far forward as it can, and its back legs are on the far side of that little wall from you, then you have it in the right place. So we're going to get our second 555 timer. We're going to do the same thing. We're going to find its little location notch, and we're going to pop it into our second board. Okay, so we have our battery connected in on the left hand side. We can start hooking up our circuit. So let's start with the connections on the boards that are to themselves. So on IC1, we're going to connect pin 2. So start in the top left, count down, 1, 2, pin 2 to pin 6 on IC1. So remember, 1, 2, 3, 4, down one side, across, and then up. So 5, 6. Now we are going to connect with a positive cable. So one of the ones with the braided sleeve. We're going to connect pin 4 on IC1 to pin 8 on IC1. Great. Now we are going to connect pin 1 to ground before I forget. So I might actually connect this one back to the battery just so I don't forget about it. Using a twisted pair, one of our ground cables, we're going to connect pin 1 of IC1 back to ground on our battery. Then we're going to take the board, the 2-pin board that's directly below the battery on the left hand side, and grab one of the resistors that we used before. These are 1 kilo ohm resistors. And what I'm going to do is I'm going to put it into the connector with the lever on the left hand side. Resistors don't have a polarity, so it doesn't matter which way round it is, just one leg is left, one leg is right in the right hand channel. But I will, for the purposes of wiring the circuit, refer to positive and ground on these boards, even when the component doesn't have a polarity. It just makes it easier to follow the circuit, I think. So I'm going to connect from positive of my battery using a braided cable to positive of my resistor that I just placed, and then going from the board negative of the resistor. So negative the resistor, I'm going to come all the way down to the 3-pin board that's on my left hand side, and I am going to connect negative of the resistor to pin 1 of that board. We're going to use it for a potentiometer, so we need to think not in terms of signal positive and ground, but in terms of pin 1, pin 2, pin 3. So that'd be a good moment to grab one of those potentiometers. Like before, we're going to pull up those levers on that terminal block so that they're pointing up towards the sky, and slide our potentiometer in and then latch down those 3 levers. Okay, nice and snug, great. Staying with that potentiometer we just placed, pin 1 is connected to negative of our resistor. Pin 2, which is labeled positive on the board, but is the wiper of the potentiometer. So pin 2 on the potentiometer is going to connect to pin 7 of IC1. And then pin 3 of our potentiometer is going to connect back up to positive of our remaining 2-pin board on the left. So I'm going to pop that into that 2-pin board. We're going to need a component for that board. So if you go back to your component box, bottom row, and then 1, 2, 3, third compartment, is a ceramic capacitor. This is a 10 nanofarad capacitor. We're going to use 2 capacitors in this just in case they get mixed up in transit. One just has a little bit of tape on it, so we're going to use the one without the bit of tape. So on that board that we just connected to pin 3 of the potentiometer, using the connector with the lever, we're going to put that capacitor in. Ceramic capacitors don't have a polarity, so it doesn't matter which way around it goes in. Dielectric capacitors do, for future reference, and they pop in a nicely explosive way if you put them in the wrong way, but this one, it doesn't matter. So we have the positive on the board of that capacitor is connected to the potentiometer, and now I'm going to get a braided pair ground cable, attach it to that capacitor, and then I'm going to connect this ground cable back to ground on our battery. Okay, I think that's everything for IC1, almost. So we're going to take another cable and we're going to connect pin 3 on IC1 to pin 2 on IC2. So just to recap, pin 1 is connected to ground on the battery. Pin 2 is connected to pin 6. Pin 3 is connected to pin 2 of IC2. Pin 4 is connected to pin 8. Pin 5 is connected to nothing. Pin 6 is connected to pin 2. And pin 7 is connected to the wiper of our potentiometer. And then pin 8 is connected to pin 4. Great. So onwards. IC2 now. We are going to connect pin 1. We're going to use one of our braided pair to connect it back to ground. This can go to anywhere where you've used a braided pair already, but I'm going to connect pin 1 of IC2 to pin 1 of IC1. Pin 2 is connected to pin 3 of IC1. Pin 3, we're going to ignore for a moment. Pin 4, we're going to get another one of our positive braided sleeve cables, and we are going to connect pin 4 of IC2 to pin 8 of IC2. Pin 5 isn't connected to anything. Pin 6 of IC2 is connected to pin 7 of IC2. Okay, cool. And now we're going to wire out to some of our components. So we're going to get another one of our braided sleeve positive wires, and we're going to connect from pin 8 of IC2 to our potentiometer board, the 3-pin board on the right hand side that we haven't connected yet. That's also going to be used for a potentiometer. So we're going to take pin 8 of IC2 to pin 2 of our unused 3-pin board. I'm going to grab our other potentiometer, connect it like we did before. So making sure the levers are up, slide it into that terminal block and then push those levers down. So on this potentiometer we have pin 8, that's a positive connection. You can tell because we've used a braided sleeve wire, a positive wire. And we are going to connect pin 3 of the potentiometer to positive of the 2-pin board, the unused 2-pin board that's just above it. So pin 2 to that one. To that we're going to grab another one of our 1 kilo ohm resistors and we're going to connect that in the connector with the lever on the left hand side. Again, resistors don't have the polarity, so just one leg in one channel and the other in the other. Then we are going to connect, we've connected pin 3 of our potentiometer to positive of our resistor, or at least positive on the board. Negative on the board, we are going to connect back to pin 7 on IC2. Now we are going to connect pin 6 of IC2 to one of our still unused 2-pin boards. So the one up, the next one up on the right would do fine. So we're going to connect pin 6 of IC2 to positive on that board. Going back to our component box, we're going to grab our other ceramic capacitor. Again, you'll feel that the legs are the same length. It doesn't have a polarity. It does have a little bit of tape stuck on it. So this is a 100 nanofarad capacitor. On the board that we just put a cable into, but that we haven't connected anything to yet, I'm going to add the capacitor into the connector with the lever, just lock it in place. And then I am going to grab one of my twisted pair cables, my ground cables. I'm going to put it into ground of the board with the capacitor, and I'm going to connect it back to any ground connection on our circuit. A good one to use might be pin 1 of IC2. Okay, super, almost there. The very last thing that we have to connect up is our speaker, and we're going to use the same passive piezo speaker that we used before. So that's the one that has 2 legs that are the same length. We have one remaining board, which is a 2-pin board up in the top right of our workspace. So I'm going to put that piezo into the connector with the 2 channels and push down the lever. I'm going to connect pin 3 of IC2 to positive on that piezo. And then finally, I think I don't have enough negative cables, but I should use a negative cable for this. I'm going to connect negative of the piezo back to any ground on the board or on our tray. So maybe pin 1 of IC2 again. Okay, that should be as good to go, unless I have missed something. I'm just going to recap IC2. So we've got pin 1 of IC2 is connected to pin 1 of IC1. Pin 1 of IC2 is connected to negative on our second capacitor. Pin 1 of IC2 is connected to negative on our piezo buzzer. Again, the piezo doesn't have a polarity, but just negative to its board. Then pin 2 of IC2 is connected to pin 3 of IC1. Pin 3 of IC2 is connected to positive on our piezo buzzer. Pin 4 of IC2 is connected to pin 8 of IC2. Pin 5 isn't connected to anything. Pin 6 is connected to pin 7. So pin 6 of IC2 is connected to pin 7 of IC2. Pin 6 of IC2 is connected to positive on our capacitor, or positive on the board. Pin 7 of IC2 is connected to negative on our second resistor. Again, resistor doesn't have polarity, but negative on the board. And then the last connection that we're going to make is I'm going to take another positive cable and I'm going to connect pin 8 of IC1 to positive on our battery. And I'm also going to take another cable and connect, I've forgotten something. I've missed a connection. Sorry, I didn't connect positive of the two boards together. So we can go from pin 4 of IC1, which is a positive connection, to pin 4 of IC2. There we go. I'm just turning the two potentiometers here to make a reasonably unpleasant sound. Cool. And if you happen to have a little speaker, I'm just going to take the piezo buzzer out for a second. If you happen to have a little speaker handy, something you can do, a speaker that has a jack lead on it. If you have two banana clips, it's not banana clips, my apologies. If you have two crocodile clips, take one and on the jack lead, connect it as close to the bottom of the jack connector as you can, so as close to the plastic housing but still on the metal. That will be the ground section of that jack plug. And then at the very tip of the connector, you can feel where there's a part that's narrower and then it kind of splays out a little bit, but somewhere just on the very tip, as close to the tip as you can get. If you connect those, and then I'm going to take those two banana cables, and it doesn't matter which way around, but the board that I just took the piezo out of, at the very front of it, there's two little notches that you might be able to feel. And I don't know if you can feel that it's metal as such, but those two notches are places where you can connect a crocodile clip. So if you want to connect a crocodile clip onto the two pads of the board that previously had the piezo, the sound is at least louder. I don't know if it's better. There's a little bit of hiss there. I'm going to presume that there's something wrong with one of my connectors to my chips slightly, but it works in a general sense. And yeah, have fun making a pretty lousy synthesizer. Thanks.